Hey math people, welcome to a calculus concept checked c cubed with m cubed. And yes, I literally just came up with that like seconds before starting this video, and I like it. So pause, you do it. Video is just paused, unpaused, let's play. What is y equal to if I know the derivative is equal to x? Well, alright, it's just taking the antiderivative. So if I want to come up with a normal y in a case like this, the antiderivative of x is 1/2 x squared, right? It's like a power rule in reverse, and then don't forget your plus c. That's it. If I have just like a constant, write it down here. It's the same story, except it's a constant this time around. It's technically like an x to the 0th there. We'll say y is equal to, well, x. Derivative of x is 1, and then don't forget your constant, plus c. Something like t, now that's something to be wary of. What am I trying to highlight in something like this? Keep in mind what variables are in play. If your independent variables at play, it's just an anti-power rule. If you're, well, wait a minute, I don't see any of those two variables in the differential in the expression dy dx here, so you can just treat this like it's a like a constant. If this was just a 3 here, the derivative is 3, then the antiderivative would be 3x. So it's kind of the same story here. This would be y to the tx plus c. And then the last case here, when your derivative is equal to the function itself. Oh, wait a minute, that sounds like a function that I should be familiar with. But here's the official process to how to handle something like this. Although technically, if you're in like at least like if you're in my Calc BC class, I would be okay with you jumping straight to the definition, because this is kind of a key component to differential equations, which actually is the inspiration for making this video. But anyway, what we would do is we would perform a process called separation of variables. So if I move this y over to the left, and I move this dx over to the right, we would get something that looks like 1 over y dy is equal to 1 dx. If I integrate both sides with respect to the variable we see present in the differential, we end up getting natural log y here. And some people put an absolute value, some people say don't put an absolute value. I don't know who to believe in this world. We're just going to omit it for now. This is going to be equal to x plus c. If we raise both of these as powers of e, this will be how we can kind of remove this natural log here. So this would be my power of e. There's this process called c absorption. This is technically e to the, you could think of this as, well, I guess I'll write it, e to the x plus c, and technically that would be e to the c and then e to the x. I'm not sure if I'm on camera anymore at this point. There's something called c absorption. This constant is arbitrary. There's no point in tracking it without context. So this e to the c, at the end of the day, is just some constant. So we can treat that as our c value in itself. You can say c absorbs e to the c if you'd like. So e to the x comes into play for something like this, which should make sense, right? Derivative of e to the x is itself. Derivative is itself. So that's a quick calculus concept check for you. Hopefully you got all 4 right. If not, that means it's not a big deal. That just means you have to think a little bit more, be a little bit more mindful of the learning process, right? It's about a lot more than just pattern recognition, right? There's some real substance behind it. Okay, have a good day, Math On, and I'll see you in the next video.